Hi, I'm going to demonstrate here how you can perform the simple one-way ANOVA using IBM SPSS. In this example, you have four groups, control rats that are receiving no treatment at all, a group of rats that received Uricoma longifolia extract, temulawak extract, and the positive control simvastatin. So then we measure the level of low density lipoprotein and high density lipoprotein. So to do this one-way ANOVA, the first thing that we have to prove is that the data are normally distributed. Okay, we can check that later, but I have shown that in my previous video, so please refer to the video on how to check the normality of the data. I'm not going to do it again. I'm going to straight away to the ANOVA. So to do this, you click Analyze. You go to Compare Means One-Way ANOVA. Okay, then I just reset it again. Okay, you transfer all the dependent variable into the dependent list and the group of rats into the factor. Okay, here you can see a button for post hoc test. One thing that I have to explain about ANOVA is that ANOVA is very good at sensing the significant differences among the groups, but it is not having the ability to pinpoint which one is actually differing. So because it is not able to do that, it requires a post hoc test to specifically identify the part which is statistically differing. I'm going to perform this ANOVA first without the post hoc test, so you can appreciate later on when I choose post hoc test in terms of the information that we are going to get. Okay. Importantly, click option. Click descriptive because we want all the mean and standard deviation and stuff, and homogeneity of variance test because this information is going to be very useful for us when we are going to decide on what sort of post hoc test to be used later on. So you click continue, then click OK. Now you can see the descriptive table. You can see all the different means and standard deviation for the individual groups. Okay. And however, we want to know which one is actually, or which are the parts are actually differing. Okay, then you look at the test of homogeneity of variance. You can see the p-value for LDL and HDL are all both more than 0.05. So what does it mean? It means that we can assume equal variances for these two groups. If the value is lesser than 0.05, we cannot assume equal variances. Why do we need to know this? Because we are going to use this later on in deciding what sort of post hoc test to be used. Then you look at the ANOVA. ANOVA is telling us that there are differences, 0.00, 0.002. But ANOVA does not have the ability to pinpoint which one among these four groups are actually differing. So that information can be very important. So now I'm going to redo the analysis, but this time I'm going to incorporate the post hoc test. So analyze, go to compare means, one-way ANOVA, and then I'm going to select post hoc. Okay, here you are actually prompted with selections of post hoc tests. The upper part when the equal variance is assumed, the lower part when equal variances cannot be assumed. So in our context, we can assume equal variances. Okay, so there are still many different post hoc tests to be chosen. So this is based on our preference, my preference. Okay, so if the number of replicate for each group, meaning that for all the four groups, the number of replicates remain the same, I am confident to choose Tukey-Kramer as my post hoc test. If they are not the same, I would rather go for Bonferini. Okay, so if the equal variances cannot be assumed, my preferred post hoc test is actually Tamhan or Dunnett. So in this context, I'm going to choose Tukey-Kramer post hoc test because equal variances can be assumed, number one, and number two, we have the same number of replicates for each group. Then you click continue, and then you see the difference now. See, we have the same table again, and in addition to that, we have this multiple comparison table. So now it's going to be more useful than the previous one. So for example, for LDL, control versus Uricoma longifolia, so it's statistically significant. Control versus temulawak, it's statistically significant. Control versus simvastatin, it's statistically significant. How about simvastatin versus control? It's also significant. How about simvastatin versus Uricoma longifolia? Oh, it's not significant because it's 0.486. So this is how you are going to get all the information that you are requiring, okay, based on the multiple comparison table by simply choosing to use the post hoc test for the ANOVA.